Isabella.
And I'm Jamie. We're going to talk about skateboards and scooters.
That's right, Jamie. Skateboards and scooters are actually quite similar because they are both vehicles that you can ride. However, let's go deeper into what their components are.
So, a skateboard has three main parts: a deck, which is actually just the board in formal terms, the metal trucks which connect the wheels to the board, and the wheels.
There are actually two types of decks. The first one is the concave curved deck that is easier to move around in. The second one is the planform deck, and this one is flatter than the concave curved deck, but this is just for skaters who want to have a cool-looking board.
However, due to limited materials, some of the scenes in this video will be shot using a penny board. Only in trick shots will a normal skateboard be used. Still, we are going to be talking about skateboards in general.
Thanks for the explanation. Now this is a Y scooter. It's different from a normal scooter or electric scooter because it has two boards and three wheels. It's actually pretty cool, right?
There are four main parts to a Y scooter: the handles, T-bar, deck, and wheels. The T-bar is used to steer and brake the scooter. Its ability to brake is one of the main parts that's different from a skateboard. Instead of putting your feet on one board, you put one on each side in a wide stance. Now, here's a short explanation of what a free body diagram is and how we will use them to explain the motion of a skateboard and Y scooter. In a free body diagram, there's gravitational force, normal force, friction, and applied force. Body diagrams are used in physics to show the different types of forces in order to calculate them in a problem.
So now we're going to show you some videos of the motion of skateboards, Y scooters, and the tricks you can do.
While a person is on a skateboard, there are multiple forces acting against them: gravitational force pulling them down and normal force from the ground pushing against them.
The same forces apply when someone is standing on a Y scooter, except that the applied force will affect some different additional parts of the vehicle.
Just like this video when I was on the skateboard, my feet pushed off the ground, applying force against the skateboard. There is friction between the wheels of my skateboard and the ground, but its magnitude is less than the applied force. And of course, there's always going to be gravitational force and normal force if the object is in contact with the surface, which it is. They will also be equal to each other.
Gravitational force is measured by the formula force gravity equals mass times gravity. Gravity's acceleration on Earth is about 9.81 meters per second squared, and is often rounded up to 10 meters per second squared. Normal force exerted on the skateboard is equal to the gravitational force.
The total magnitude of forces acting on the skateboard can be calculated with the formula for net force. Net force equals mass times acceleration.
After the initial kickoff, you will remain in motion with the skateboard for a few seconds before you start slowing down. This is due to the frictional forces that will hinder the motion of a skateboard.
Here, you can see the skateboard gradually slowing down after being pushed. This is due to friction.
Static friction is what an object experiences when at rest, while kinetic friction is experienced when the object is moving. When calculating friction, the formula used is forced friction equals the coefficient of friction multiplied by net force. Kicking off the Y scooter is very similar to a skateboard, except after the initial force against the ground, you will put your feet onto a separate board instead. To keep yourself in motion, you can simply continue pushing against the ground.
Now that you know the basic motions and how to use a skateboard and Y scooter, here are some physics behind some of their common tricks.
To do a hippie jump, you start on a flat horizontal surface before jumping up, but without forcing any horizontal force on the board. This allows the skateboarder to fly through the air at the same velocity as the board, so they can land back on top of it.
The skateboarder needs to push down vertically when jumping. Any horizontal force will make the board go farther forwards or backwards. It will follow a parabolic arc when jumping through the air as a result.
Here is another basic trick, the ollie. Remaining in a stationary position, the skateboarder pushes down with both feet, with the force in one foot larger than the other.
Nice. Wow, but how does an ollie relate to physics?
Well, we have to go back to one of the things that we learned earlier in the year, which is Newton's third law. Newton's third law states that for every action, there's an equal and opposite reaction. This is one out of the three laws of motion that Isaac Newton discovered.
Isaac Newton was a famous mathematician and physicist who was best known for the three laws of motion and discovering gravity. Have you ever heard the myth of a guy who got hit by an apple from an apple tree and had an epiphany about gravity? Well, that was him, Isaac Newton. Now that you know Newton's third law, let's apply this to the ollie.
When you're doing an ollie, you have to keep one foot on the board and propel yourself forward with the same amount of force that you push backwards. The downward push, or shall I say downward force, will cause the board to launch back into the air.
Torque is the force that causes an object to rotate on its pivot point. It requires the object to have an angular acceleration.
Here, the skateboarder was able to skate up onto the ramp due to momentum and inertia. Momentum is calculated with the formula P equals mass times velocity. Inertia comes from Newton's first law, stating that an object in motion will stay in motion unless it's impacted by external forces, just like friction. This is why, despite gravitational forces, the skater was able to go up onto the ramp without falling down right away. We hope you enjoyed this video, and here are some bloopers.
Oh shoot! The other deadline. Can we do that?
Yeah.
Okay.
I'm gonna write on.
Yeah. And now for the credits.